Hi guys, so today we're going to be discussing Leetcode question 21, merge to sorted list. So the question is, you are given the heads of two sorted linked lists, list 1 and list 2. Merge the two lists into one sorted list. The list should be made by slicing together the nodes of the first two lists. Return the head of the merged linked list. So essentially, let's say this is the linked list that we have. Let's say we name this C1, this one, and this is C2. And this is the merged linked list, right? So if C1 starts from here and C2 starts from here, since these two nodes are same, so we just append them one after another in the merge linked list, and then we move C1 here, move C2 here. 2 is smaller than 3, right? So we need to keep the order sorted. So we first add this C1 here. We first add the C1 node, which is here, and then we move C1 ahead. Now we compare C1 and C2. C2 is smaller, so we add C2 now, which is 3 in the merge linked list, and then we move C2 ahead. Now these two values are the same, so we append them one after another, and this is our merge linked list. Similarly, in a different example, let's say this is again C1 and this is C2. So C1 is here and C2 is here. So essentially, in the first step, C2 is smaller than C1, right? So we put this here in the merge linked list. This is the merge linked list. So we put the C1 node first. Sorry, C2 node first. My bad. Once we are done with that, then we increment C2 to point to the next node. Now C1 and C2's values are same, right? So we add them both together and then move both of them ahead by 1. So this becomes C1 and this is C2, the new positions of that. C2's value now is lesser than C1's value, so we add C2 first to the merge linked list. So this is where we add in our merge linked list the node 3, and then C2 is null, right? So now when C2 becomes null, when one of the linked lists becomes null, that means there's only elements left in the other linked list, right? So we just keep appending everything one by one from there. So we just add the node 4 from C1, and then the node 6, and then the node 8 consecutively. So 4, 6, 8 in the merge linked list. So I hope you understood why are these two examples, what are we supposed to do. So I've written down the algorithm below for this example. So what are we supposed to do? So while both lists not equal to null, basically there are elements in both lists to traverse. So then what do? We check which one has the greater value. Whichever one has the lesser value, let's say in this case C2 has the lesser value, right? So we add C2 to merge to the merge linked list and move C2 ahead by 1. This is what we did up ahead. And if C1 value is lesser, that means this is the scenario that we're talking about. Then add the lesser value to merge and then move the lesser value pointer ahead. If both are equal, the third scenario, the third green line that you can see, if both are equal, then just add both of them to the merge linked list and move both of them ahead by 1. So C1 also increases, C2 also increases. We keep doing this until and unless one of the list becomes empty, that is completely traversed. Once that happens, so that means one of the two linked lists is empty and one is still remaining. So either of these conditions will follow. So either while C1 is not yet null, that means there are still elements in C1 if there are. So just keep adding C1 elements one by one and keep incrementing them. And if not, if C2 is not yet null, this last scenario, that means there are still elements in C2 to be iterated and C1 is empty. So just add C2 elements one by one and increment C2, then add another C2, then increment C2 pointer by 1. So let's see this algorithm in action. For the example, let's say this is the example that we have 1, 2. We'll just take an example from above. So this is C1 and the C2 is 2, 4, 6, 8, and this is C2, let's say. So what would our merge linked list look like? So note that initially C1 is here, C2 is here, right? And this is null. So our algorithm says, well, both nests are valid and both are not null yet. So just keep traversing. In what order? First check if the current pointers which nodes to they point to, if their values is less than or greater than each other or not. So in this case, C1's value is less than C2's value, right? So we add C1 first to our merge linked list. This is C1. This is the merge pointer. I'm just writing merge pointer, right? So we add C1 here and then move C1 ahead and then move C1 and then move C1 ahead by 1. So basically this is the scenario that we will encounter, the second if condition. So now we compare C1 and C2 and notice that the merge pointer also moves ahead now for the new linked list, right? It will start appending from the next point. So now that this has happened, my bad. So now we compare C1 and C2. C1 and C2 both have same value, so we add both the nodes just as this third if condition says. This third if condition, if both are equal, add C1 and C2 to merge. So we add both C1 and C2 and then increment both by 1. So C1 becomes this node and C2 then moves ahead by 1 to this node, node 4. Now that we have done this, we look for another iteration. Now we compare C1, C2. C1's value is less than C2, right? So this second if condition is encountered. Since C1 value is less than C2, so we add C1, which is 3, and just increment C1 by 1. Now C1 becomes null. So this condition, that the first while condition that we have, while both less is not equal to null, this is stopped because we have encountered the end of one linked list, right? So that means we just have to work on the second linked list and append all the elements of it to our merged linked list one by one. So this essentially results in, since C2 is here, right? So we start from C2, add 4, move C2 ahead. This becomes C2. Now we add 6. We move C2 ahead. Now C2 is 8. So we add 8. Now C2 is moved ahead. C2 becomes null. So we put a null here and we stop in the end. So this is our final merged linked list. So I hope you guys understood the algorithm via these different examples and a dry run as well. I have attached the link to my GitHub repository for the code for this problem below in the description. Please feel free to check that out. I have also attached my social media links in the description below. Please feel free to check them out as well, and feel free to leave any comments or feedbacks in the comment section below. Thank you for watching this video. Have a nice day.